Hello guys, welcome back. This is your host Pro John Mandona, and we are going to continue from where we left off. But before anything else, I want you to subscribe to my YouTube channel so that you can get the latest videos, the latest information that you require. So we're going to continue in chemistry. So our lecture today is based on atomic structure. So we're going to know about the atomic structure. So let us dive in. So about the atomic structure, we need to understand how a basic structure of an atom looks like. So a basic structure of an atom actually has two parts, and these parts are the nucleus, and the second one is the energy level. So along the nucleus, we actually have protons and the neutrons. The nucleus is the central part of an atom containing these two subparticles, and the protons are positively charged and the neutrons do not have any charge. And we also have the energy levels, which are the rings that surround the nucleus, having electrons with a negative charge. So this is a simple representation of a basic structure of an atom containing the nucleus at the middle having a positive and a negative and a no charged neutron, and we also have what we call the energy levels, and along the energy levels that's where we're going to find some electrons with a negative charge. So now we actually need to understand what we call some assumptions that earlier scientists made on the structure of an atom. So one scientist actually depicted to say an atom looks like a solar system where we have the central part, which is the nucleus, like the sun, and you actually have planets that revolve around it, and these planets actually are electrons. So electrons actually move or orbit around the sun, or orbit around the nucleus, just as planets orbit around the sun, and their distances are held firmly in a fixed position due to some electrostatic forces between the electrons and the protons. These electrostatic forces are forces of attraction between the electrons, which with a negative charge, and the proton with a positive charge. And this assumption was made by Bohr. So this is Bohr's model on the structure of an atom, and this is what he actually says, that an atom is a very small positively charged having a positively charged nucleus, which means the protons are positively charged, and also surrounded by electrons which are negatively charged, as we can see, and they're held together by electrostatic forces, which makes the electrons to move in a circular orbit around the nucleus. So the other thing that he actually made to say, that under the Bohr's model, we actually have what we call energy levels. Energy levels are shells. Those are the rings where the electrons move, where the electrons are found. So electrons can actually move from one energy level to another energy level. We're going to explain that characteristic later. But each energy level has its own fixed amount of energy, so which means the energy level that is closer to the nucleus has the lowest amount of energy, and the energy level which is far away, farther from the nucleus, actually has a higher amount of energy. So I'm going to how we explain this in the next slide. So let us hear the assumption that Bohr model made. And the assumption is that electrons are negatively charged that revolve around the nucleus with a positive charge, and they move around an orbit, as we explained, in form of the solar system. And the other thing is that each orbit or each shell, each energy level, actually has a fixed amount of energy, and that fixed amount of energy moves along a very, very circular path, which are known as orbital shells. So now let us give an illustration. An illustration is that The shell, the shell that is closer to the nucleus, the inward shell, this one, I'm going to call it the first one, the first shell. This first shell has low amount of energy. The first one actually has low amount of energy. The second one has a bit higher than the first one. The third one a bit higher. The fourth one a bit higher. But one thing that you're supposed to know is that as you go from 1, 2, 3, 4, 5, as you continue to increase, let me set an arrow. As you continue to increase, the energy increases. Let's see if I can write the word increases. No, I cannot write that word. The energy increases. So as the energy increases as the shells continue to increase in their number. So the lowest shell is known as the ground state because it has the lowest amount of energy, and each shell has its own quantum number. The quantum number is actually the number given to the shell. So the quantum number is represented by n, so which means the first shell is n is equal to 1. The second shell is n is equal to 2. The third shell is n is equal to 3. Don't mind the way that I'm writing. The fourth shell is n is equal to 4. And the number of shells continues to increase. So given an example of a hydrogen atom, and a hydrogen atom only has one type of only has one electron in it, so which means that it might have a lot of shell but one electron. So since it has a lot of shells but one electron, so it means that electron is going to be placed in that position. So since we only have one electron in it, and we only have one shell, one electron in it, and we have a lot of shells, so which means this electron has a capability of moving from the lowest shell to any shell which is after the first one. So this electron can move from the first shell to second, third, or fourth, but it is only possible if energy is absorbed by electron. So which means the electron is going to absorb energy or gain energy, and if it's gaining energy, it is going to move from the first shell to any shell above it. And it is also possible to say that if an electron is in any shell which is maybe maybe 5, 4, 3, 2, any shell. Let me give an example. Maybe an electron is there. It means that it can move to any lower shell. Let me say the quantum number n is equal to 1. It can move in that direction, but it is only possible if at all it loses energy. So what happens is that if an electron loses energy, it means that that energy will actually have a negative. And if an electron gains energy, it means that the energy is going to be a positive. The energy of that electron that is gained will be positive, and the energy the electron has lost will be negative. So now we continue. So I'm going to explain what these initials are, but quantum number 1 is represented by K, quantum number 2 is represented by L, quantum number 3 is represented by M, quantum number 4 is represented by N. We are going to explain what these initials are as we proceed. So as I have already explained, to say that the more the number, the more the more the shells increase, or the more the quantum number increases, the higher the amount of energy that shell possesses. And the lowest shell with the lowest energy is known to be that the electron is in the ground state. So when you hear that the electron is moving from the ground state to any higher energy level, it means that it is moving from energy level n is equal to 1. And an electron can move from one shell to the other if at all it gains energy or loses energy. And it gains energy, the electron gains energy only if it is moving from a lower energy level, only when it's moving from a lower energy level going to a higher energy level, and it loses energy if it is moving from a higher energy level going to a lower energy level. That is how it loses energy, and the energy will be negative. So this was the illustration that I actually gave to say an electron will move from the lower energy level to any higher energy level, and it is going to gain energy. The electron will gain energy for it to move, and the energy will be positive. An electron can move from a higher energy level to any lower energy level by losing energy, which makes it to have or possess a negative charge. And the Bohr's model wasn't perfect, and it was improved to the knowledge that we have today. But its limitation that it had is that it did not explain what we call the Zeeman's effect. So if an atom is passed through the magnetic field, it is going to release some light which has different wavelengths, and it is called a spectra. So as it emits this spectra, the Bohr's model did not explain how was the spectra emitted. Why do they have different wavelengths? It did not explain such a property. The Bohr's model also did not explain what we call the stack effect. The stack effect is somehow similar to the Zeeman's effect, but the difference is that the Zeeman effect focused on the magnetic field, whereas the stack effect is an electric field. So they all emitted the spectra, and that spectra the spectra has light with different frequencies and different wavelengths, and did not explain what brought about the differences, and also why are they emitted. It did not explain such a characteristic. And also it violates, or it went against, the Higgs-Boson uncertainty principle. And what it states is that we cannot know both the position and the momentum of an electron. In this case, for Bohr's model, he illustrated to say that maybe the electron is in the first shell moving to the third shell. But in this case, Higgs-Boson said that no, we cannot know the exact location of an electron. So since we cannot know the exact location, and we can also not know the momentum, we cannot know both at the same time. But how is it that he was able to know both? So which means that he failed to explain such a property. And I would love to say thank you for watching this tutorial. I really enjoyed explaining this to you. I hope you really gained something from it. This is only an introduction to the Bohr's concept, but in our next video I'm going to explain deeply on the Bohr's model and how to calculate if we have an example of a hydrogen atom. So before anything else, I want you to subscribe to this YouTube channel so that we can get the latest videos and the latest concept. Thank you very much. See you next time.